So like I said, what we're going to focus the majority of the time on today is this app-to-app messaging service. And this follows a very similar flow as our private document exchange service, where we have the ability for different programs, different client applications to securely communicate with each other. So this could be just an ACK-NACK, this could be a finance, this could be I guess a litany of circumstances where we don't need large payloads being transferred, but we need, small frequent messages being exchanged across your business network. These can go hand in hand with a lot of the other services we have on Kaleido. But at a very high level, how this works is this is going to leverage our on-chain registry, what we call our ID registry, that has organizational enterprise identity constructs, digital X509, PKI-backed certificates. These can go through a self-signed Kaleido ceremony, or you can go through your own key ceremony, create a certificate signing request, and send these objects up to a reputable certificate authority, a DigiCert, a VeriSign, a whomever. Once you've established those on-chain enterprise identity constructs, beneath them, you can start to have key value pairs that have impact on your organization in Kaleido. One of these key value pairs that we're going to use today are what we call destinations. You can think of those as the inbox or the topic that the application wants to subscribe to and wants to communicate with. And associated with that inbox or that destination is a public certificate. And this is where we leverage asymmetric cryptography in Kaleido. We have client A in the demo I'm going to show you. We're going to have a sender and we're going to have a receiver. And the sender, client A, is going to use the public certificate of client B to encrypt those payloads, ensuring that only the counterparty, only the recipient of these messages is going to be able to decrypt them. This will be the only individual, the only organization, the only entity in the network that has the corresponding private key with their public certificate. So it's very, very basic asymmetric cryptography, but the actual security and the transfer of that is a non-trivial action. So this is really, really powerful in an enterprise context. And again, if there are any questions about PKI, about how Kaleido does identity or about the services, just throw them into the chat. Okay, so I have a consortium, I called it Example Network Consortium, and then I have a handful of environments. I'm going to try to go through this from scratch live, but if I get in a pinch, I have a prod environment that has some existing app-to-app services, has all the identities instantiated on the chain, and it has all those destinations created. So we'll try to do this from scratch, but if we're unable to, I may hop back to this prod environment where I've already confirmed that everything has worked. Okay, so the first thing to take note of at our consortium level are our memberships. These are our organizational identities. In this circumstance, these are both owned by my organization, but when you start decentralizing your business network, your consortium, you're going to have autonomous unilateral individuals and organizations that are in control of their memberships. So just imagine that these were owned by different organizations, that they weren't owned, solely by me. And then what we see here next to it is we see a certificate on each of them. And what I've done is I've self-signed a certificate. I've created an organizational identity for each of these memberships. And this can then get married with an Ethereum address. And this forms the top level, I guess the top of the pyramid or the top of the ladder for your organizational identity. So there's two flows that happen in this circumstance. You have to prove that you have ownership of the corresponding private key to the certificate. And then when you want to layer on key value pairs within the iChain registry, you have to prove that you have control of the private Ethereum key. And we'll actually take a look at the service, and this should make a little more sense. But what we see here at the consortium level is every participant, every organization has the ability to download and parse this public certificate. So they're able to download that and they can parse that back up to ideally what would be a reputable certificate authority. A lot of those constructs that we talked about, these asymmetric cryptographic approaches that we have, they're mandated on the existence of the on-chain registry and organizational identities. So Kaleido gives you this self-signed approach so that you can leverage these constructs without having to do an inordinate amount of key management, become an expert in, cycling keys and cycling certificates and doing certificate signing requests. So we give you basically both ends of the spectrum. You can have full control of all of the private keys for signed verify operations for your organizational identity, or you can use the Kaleido easy buttons, or you can kind of meet in the middle and do a combo of each. So however comfortable your organization is with key management, with doing sort of sophisticated, elaborate application development and handling all of these sign verify operations programmatically, you have that option, or you have the absolute easy option where you click a couple buttons and Kaleido is going to do all that heavy lifting for you behind the scenes. Okay, so let's hop back to the network and now let's go into our environment. So here's my demo environment. I stood up a handful of nodes. 2 of them are owned by ABC, one's owned by XYZ. This is an IBFT environment, so I went with 4 nodes total. And then we see here that we have our on-chain registry service. So I'm gonna go ahead and hop into this service, and we see that we have those 2 certificates. We have those 2 self-signed organizational certificates. I took the easy route rather than doing my own key ceremony. But now what it's asking us to do is it's asking us to take a proof of that certificate and some arbitrary Ethereum address where Kaleido is going to control that key and create an on-chain profile. Actually upload this data to a smart contract on Kaleido. And then once we do that, those destinations, those inboxes, so to speak, and those corresponding certificates, those are going to get to live as children, as key value pairs within this smart contract. So we'll just go with the happy path here and establish the ID for ABC and XYZ. And again, if something goes wrong, I'll just hop back to my existing environment where I've already configured all of this. So this is an actual on-chain transaction. This is an invocation of our on-chain registry smart contract where we passed it a proof of that cert and we passed it some additional details. So I'll establish the identity of both of these and then we can take a look at how that looks within the scope of that smart contract. Okay, so here's our 2 memberships. So here's ABC, excuse me, we have the PKI identity. We can download that proof, that JWT, and we can also download the certificate. And we see here that there is an Ethereum address associated with this organizational identity. If you do this key ceremony yourself, of course, you're gonna own the private key for this Ethereum address. In this context, it's really just a convenience utility. So here's the profile for ABC. We see that there's no key value pairs underneath it. This is what we're ultimately gonna populate. And then here's the profile for XYZ. Same stuff with no key value pairs beneath the profile. Okay, so that was step 1. Now we wanna go ahead and create 2 app-to-app messaging services. We want each of our memberships to have a service instance. So I'll just use the Kaleido convenient drop-down button. Again, this could be deployed with an administrative API. Everything I do here that I'm gonna show you can be done with an API. So I'll grab a service for ABC, and then I'm gonna grab a service for XYZ. And we'll give these guys a few minutes for those pods and those containers to properly come up. So we'll drag our feet here for about 20 or 30 seconds and we'll let these services come up. And again, if there are any questions, feel free to raise your hand or just go ahead and throw it into the chat. And yes, this will be recorded for folks that are curious, and we're happy to share all the slides and even recordings of previous Tech Tuesdays and Walkthrough Wednesdays. While I am dragging my feet, allowing these services to come up, here's the first guy, made it up. I should note that tomorrow, noon Easter, we're going to do a walkthrough of Corda on Kaleido. So we are now truly multi-protocol, offering all of those great enterprise variants of Ethereum, Geth, Quorum, Hyperledger, Besu. But now Kaleido also fully supports Corda OS with a fully managed non-validating notary. So if you are comfortable with flows and Corda contracts and jar files and core dApps, that may be something that's really, really interesting to folks. And the ability to just kind of see Corda in the context of Kaleido, going through these exact same flows and these exact same processes, but dealing with a completely new and different protocol. It's quite exciting. So I'm going to do a hard refresh and see if this guy is waiting to come up. Okay, so there he goes. All right, so we have our 2 service instances, right? And again, the most important construct that we need here is we need a destination for each of our services. There's going to be an API, there's going to be a Socket.io WebSocket connection that's available for the applications to connect to, but they need to have those PKI constructs. They need to have those inboxes or those destinations that have the certificates associated with them. And the prerequisite before we could create those certificates, remember, was we needed to establish those organizational identities on the blockchain within that smart contract. So I'm just going to rename this right here if possible. Okay, looks like that's not possible at the moment. So we'll go ahead and create the destination for the ABC instance first. So it says that we've deployed the on-chain registry and we've registered our membership on-chain. That's great. So now we can go ahead and create the name for our membership. Now, again, if you do want to do the fully managed, I guess, key custody for these certificates, for these PKS7 certificates, and for all of these sign verify operations, Kaleido is going to say, okay, you can go that route and we'll give you ad nauseum documentation taking you through it. If you do want to just let Kaleido create those public-private key pairs and certificate, you can go with the easy route. And that's what I'm going to show here. So we're going to create an inbox or a destination that's called ABC here in this circumstance. And then after this works, we're going to go ahead and create a destination for XYZ. And then we'll configure our applications, our sample apps, and we'll start interacting. So here we see the two important endpoints. This is going to be for the Socket.io connection, and then this is going to be the actual inbox that one of the entities, one of the organizations is subscribed to. Now, bear in mind, you can have many, many destinations or many, many inboxes within your service instance. So it's very easy to compartmentalize and separate your different business segments and your different business logic. So you're not limited to a single service instance, nor are you limited to a single destination within that service instance. So you can go as broad or as granular as you'd like to here. So I'm going to hop out of this. I'm going to go into the XYZ instance, and we're going to do the same thing. Click the Add Destination button. Now, some of you that have been participating in these walkthroughs and have seen the new version of Kaleido, the next gen or the V2, may be wondering why I'm using the old console. And the answer is we haven't migrated the entire suite of Kaleido services to the version 2 of the console. Some of the ones that are going to be coming online here in the very, very near future are our B2B communications. So our document stores and private document exchanges, as well as this App2App instance here. We're also going to see a revamped version of the on-chain registry smart contract and our Ether faucet, just to name a few. Okay, so here we can see our owned destinations, the XYZ destination that I just created, and then we can see all of the available destinations that we could send data to, that we could use for our App2App messaging instance. Okay, so now the last thing we need to do is we need to go ahead and configure our two applications that we're going to demonstrate here. So I'm going to hop back to ABC's instance, and the scenario that I'm going to show, as I sort of tried to talk through in the diagram, is we're going to have the ABC instance, the App2App messaging instance, be the sender of some arbitrary string, some message, right? Some ACK or some, payment information, some data that fits into your business use case. And that's going to travel through the Kafka plumbing, through Kaleido, and then that's going to be received by an App2App instance for XYZ in our circumstance. They're going to be subscribed to their inbox, and they're going to get automatic real-time notification when any messages are delivered to that inbox or to that destination in the Kaleido nomenclature. So that's the story that we're telling here. And then here's the app that we have. So I have an App2App library here, and we have two programs. We have two Node.js programs, a sender and a receiver here. And these are kind of the endpoints that we're concerned with. We need that API endpoint for the Socket.io connection. We need secure application credentials, right? There's boundary security on every ingress and every service in Kaleido. And then we need to know about the inboxes. We need to know about our inbox, right? This is who we're signing on behalf of. And then we need to know about our recipient's inbox. This is who we're encrypting on behalf of. And then we have a simple little string here that we're passing as our content, and we're choosing the interval and milliseconds of how often we're going to send this. So when I kick off these applications, you're going to see a ton of messages just get pelted into the receiver's program or into the terminal that I'm using to show that. So we need to go ahead and configure these strings, and we'll start with the API endpoint for the WebSocket connection. So this is for ABC. So we'll go ahead and grab this guy, make sure I'm in ABC. I am, okay. And we'll just start overwriting these placeholders that we have here. So we'll paste that. Now we'll go ahead and do the destinations. This will be the ABC destination. This will be the XYZ destination. So I'll copy that right there for ABC. We'll overwrite that placeholder, and then we'll copy the destination for XYZ. And I have this all available to me on a single screen, and I could also retrieve all of this via one of our APIs, a service or an admin API. Okay, so we'll paste that. I'm going to leave it at 2000 milliseconds, and I'm going to leave it as testing 1, 2, 3. Nothing exciting today. But the last thing that we really need, this would not work without it, we get a 404, is we need these these strongly generated application credentials. So I'm going to hop out of here, and I'm just going to go with the classic route of creating app creds. So we're creating these for ABC, call them whatever you want, ABC 1, 2, 3, click next. And again, Kaleido doesn't store these. This is salt hash on the server side on the back end. So you as the operator, you as the admin, you as the developer, you need to have your own custody techniques for these application credentials. You can always regenerate new ones. You can always cycle them. You can always delete them, but they're not going to be persisted. That password will not be able to be shown to you again. So let me make sure I've copied this. And then we'll overwrite these last couple placeholder values here. And we'll grab the password. Okay, so let's save this. So we're good with the sender program here. We updated our 2 destinations. We updated our API endpoint for the Socket.io connection, and we just created some application credentials. And now we need to do kind of some of that same heavy lifting for the receiver application that we have over here. This is XYZ again. So hop out of this. Let's go into the XYZ instance for App2App messaging, and let's copy its API endpoint for that Socket.io connection. And all of this code, all of these steps are available in the Kaleido docs. So this isn't proprietary code or isn't any custom code that I've created behind the scenes here. This is available for everyone to leverage, and all of these APIs are really simple and really easy to understand. So the last thing I need is I need the destination. This is what the receiver program is going to subscribe to. He's going to be listening on this and say, hey, let me know every time an app or a message is sent to this endpoint, or this inbox rather. So this is what he's subscribed to. And then the last thing we need is we just need some application credentials for this guy as well. So we'll go with the same route. Switch our membership, XYZ. Again, call them whatever you want. This is just an arbitrary string. And then save this. Okay, so now the moment of truth. If I've copied and pasted everything properly. So let's save our 2 programs. And now we can go into our terminal. So here's proof that it actually worked earlier, but that's less exciting than seeing it work in real time. So the sender is on the left. This is the ABC instance, and the receiver is over here on the right. And again, this is just a basic little node program. So we can kick off the receiver over here, say node receiver JavaScript. Okay, connected subscribe, that means my endpoints were good. And then node sender. And this will actually take maybe 10 or 15 seconds. Oh, okay, so I misconfigured something for our sender. No problem. Let's go ahead and make sure we got everything right for the sender. Bear with me, sorry about that. Okay, back to the sender. Okay, API endpoint, copy that. Paste that. Application credentials, from and to. Let's make sure we got all of these right. So here's the from endpoint. And let's go grab the to endpoint. And if someone sees in the chat something that I did wrong, go ahead and tell me, and it'll save us all a little bit of time. So go ahead and grab that for XYZ. And make sure we got these application credentials right. So hopefully I can get this to work for everyone. Even if it doesn't work, I think the entire flow kind of should make sense here of how we're doing that asymmetric cryptography, of how those on-chain profiles work, and basically how these messages are exchanged. So I'll give it one more shot here and see if I can get this right. All right, one more go. If it's not meant to be, it's not meant to be. So let's try again. Node sender. Okay, so that looks good. I must have messed up the application credentials, and then node receiver over here. Okay, so the messages are being sent. We need to kick off this program so he can consume that inbox, so that he can consume that destination. And again, this will probably be, I don't know, 10 to 15 seconds, and then we'll see a huge stream of messages come in, and then we'll see them starting to be updated in real time as well. So we can look down at the bottom of the terminal, and we see that these are unique messages with a different timestamp coming in, and we see the corresponding timestamps over here as well, 889, 987, 889, 987, etc. So, okay, glad I was able to remedy that. It seemed to be a simple error of application credentials, but these things happen, and this is also testimony and proof that, you know, every ingress and every endpoint on Kaleido is securely protected. So you do need to have those credentials and all of those security measures in place.